Welcome to the companion video for the article about Pandas aggregation function. In this video, you can practice the things that you have read in the article, or you can just sit back and watch me do the coding examples. What I have prepared are short instructions in all the cells, and you can pause the video at any time and try to complete the instructions and see whether you can do it all by yourself or whether you need my support doing that. So let's start with the basics. We will import pandas. So I will call the import function, call pandas as pd, which is convention. What I will actually do is I will spell pandas wrong to show you what happens if I make a mistake. So there is no module panda, so pandas will actually help us and say no module named panda. And this is a very helpful tool that will support you in the process of reaching your goals with pandas. So I will correct the name and I will execute the line, and the error message disappears, so we know that the line has been executed correctly. Show folder content. What pandas has is magic functions. So I can do a %sign, and then since I'm on a Linux system, I can use the bash commands. I can just say ls and execute the line, and then I see the actual directory where my files are located. And so I know that the FIFA cleaned CSV file is the file that I would like to work on and that I would like to import. This is also the only CSV file in this directory. So I can go to the next step, create a data frame and load the data as a CSV file, and then we have the name of the data frame here. So I will copy this here, and then I will say equal, and then I will call pd for pandas. We have imported pandas as pd, and then I will say read CSV, and in parentheses I will copy the name of the CSV file and insert it here. And now we will execute the code, and we again have no error. And now we will look at what we have produced. So I will start typing df and autocomplete, because this is the only data frame we have at the moment. And then I will call the head method on our data frame. And so we see this is our data frame. We see the rows and the columns, and we see a little summary. So we now, with the head command, see the first 5 rows of our data, and we know that there are 92 columns that extend further out of the screen. In the next section, we will create a subset of our data and work with that subset and apply the aggregation function to that. Welcome to the second section of this video. What we have done thus far is we have created our data frame, and we have called the head method on our data frame, and we have seen that it has 92 columns. It's very difficult to work with 92 columns, at least in a tutorial setting, so we will reduce those columns to those mentioned in this section. So right now would be the time to pause the video and complete these 2 steps, and I will start now doing those steps. So what we know is we have the data frame and we will create our subset. This is the name of the subset, so I will just copy it in here, and then I will do some square brackets, and I have been lazy and have copied out the column names, so I will copy those and insert them here. So what's important to pay attention to is that we have two sets of square brackets at the beginning and at the end, and this is a requirement in order to create the subset. So I will execute the code and we will get an error. Soccer player subset. Yes, that's the other way around. The soccer player subset doesn't exist. So what I actually need to do is, this is, you see the error functions are very, very helpful. So what I actually need to do is I need to take the subset out and include the subset here, and here I'm referencing actually my data frame that I have created here that already exists, that we have called the head method on, and now we'll execute the code and the error is gone. And now we will have a look at our new data frame. So if I call df, now I have two data frames. I will select the subset and call the head method on the subset and execute the code, and we see this looks much better. So what we have is, I have chosen following columns for this tutorial. We have the nationality, we have the age, height in centimeters, weight in kilograms, overall rating, which shows how big of a talent the player is, whereas the highest possible rating is 100. Value in euros, this is the value of the player as estimated by FIFA, and wage in euro. As far as I understand, this is the monthly wage. Okay, so this is the data set that we will work with. Now you can move on and pause the video and do the basic aggregations. Okay, so what we will do now, we will use our subset and call the describe method on our subset. So in order to do that, I will do df autocomplete and select subset. In order to start the autocomplete process, you just press the tab key on your keyboard, and Pandas will suggest you the options that are available. And now I will call describe and add some braces and run describe. So what describe does is, it's a very, very helpful aggregation function, and here we see what aggregation actually means. We have many records. Let's actually, yeah, we see the count of records. So we have almost 18,000 records, and those 18,000 records, this is such a volume of records that it's very hard to look through them and to get a good view on what kind of data we're dealing with. But here with the describe method, we're actually seeing aggregation functions that have been performed on our data and that show us, that describe certain aspects of our data set and of our data. So we see the count, and we see that almost all columns have the same amount of values. But we see that the value in euro column has less values. So it's 17,954 and here it's 17,699. So we know that certain values are missing. And the wage column has the same issue, so there are certain values that are missing. We have, we see the mean of all the columns. We see the standard deviation. We see the minimum and the maximum, and then we see the 25%, 50%, and 75% the values that are found at this breakpoint. Calculate the sum of all values in the column value euro. So what we will do here is we can either use our subset or we can use the original data frame. That doesn't really matter because we will limit it to the actual column. So in this case I will just use the entire data set, and then I will call braces and include the value euro column, and then I will call the sum function on the column. Let's execute it, and here we see the sum of all value euro records, so summed up into one number. So this is also aggregation function where Pandas goes through and adds up all the values available and returns us the sum. Welcome back to the next section. In this section we will use the aggregate method on the series data. Let me execute this cell again. So a series is represented by one column. So a data frame consists of one or multiple columns. It's just like an Excel spreadsheet table, and the series is actually one single column. But we will investigate this further in this section. So right now is the time to pause the video and try to complete those action points by yourself. Okay. From our data frame, isolate the series wage euro. Okay, so let's do that. We call our data frame. Because we're working with the series, there's no real use to call the subset. We can just use the entire data frame, and then we will use square brackets, and we will actually define the column that we're interested in, which is wage euro. A very helpful thing in Pandas is that you can execute parts of the code. So this is not the entire code that is required of us in this section, but we can start here and execute this code, and we can actually have a look at it. When you look at this code above, you see that the formatting is different. Here the formatting is more elaborate. There are different colors, different rows. This is actually what Pandas formats a data frame like. And if you see down here, this is much simpler. It has an index that was created. There's this jump between the first 5 records and the last 5 records that is shown to us by those 3 dots, and these 3 dots mean that there are many records between those two extremes. So we know that we have been successful isolating the series, because this is what a series looks like. And now we will use the aggregate function and pass in a list of aggregation functions. So what we will do right now, to our series we will apply the aggregation function. And within the aggregation function, we'll actually copy our list of functions, insert it here, and let's execute. Okay, wonderful. So what we see here is that on our series that we have isolated here, we have applied the aggregation function, and now we see the sum, the min, the mean, the standard deviation, and the max values. The functions that we have defined here have been applied to our series. And the last job that we have to do is store and return the result in the variable wage stats. So we will copy wage stats and we will go here, insert it, and say equals age stats, and we will execute. And whenever we create a new variable, the Pandas doesn't display the output. So what we have to do is we have to call wage stats and now execute the cell again, and now we have completed all the tasks in this point. So whenever we need this data, we can just call the variable wage stats, and every operation that we have performed here has been stored to this variable, and we can simply output it by calling its name. Check the data type for wage stats. So this is where Pandas really shines, because we can actually use the Python functions like type and pass in our variable wage stats and execute the cell, and Pandas, and we actually see the type that this is a Pandas core series. So we know that our isolation process has been correct and that we are really working with a series. So we see, we actually learned something about this series here. So what I will do to show you what I mean is I will actually execute this part of the code one more time. And just to illustrate, and okay, this is actually not what we wanted. This was the memory position. So what we did here is I pasted this code in here, and I will execute it now. And you see that Pandas only displays us the last line of code within a cell. So what we see here is that Pandas has created a numeric index, and this is a series. But a series can also look differently. It can also work like a dictionary and contain key value pairs. And if I remove this line, this is actually what you will see. Pandas has used our functions sum, mean, standard deviation, and max to create key value pairs. It has performed the aggregation operations over the data column over our series, and has created a dictionary pretty much, where we have a key and then the value. And those key value pairs have the type of series. So a series is a very powerful object in Pandas and has the power to display key value pairs. Okay, let's look at the next section. Isolate the minimum value from the series wage stats and store it in the variable wage stats min, return wage stats min. Okay, let's start with that. No, let's do it step by step. So isolate the minimum value from the series wage stats. So we will call wage stats, and we will actually do min and execute. So what we have here is the minimum value. By the way, I haven't mentioned it. I mentioned it in the article, but I haven't mentioned here. This is scientific notation. This plus means that the separating dot has to move 3 times 1, 2, 3 to the right. And I know that it's to the right because there's a plus sign. If it were a minus here, then it would be moving the other direction. So what we see here is this is scientific notation, and the output here 1000 is actually the same value as is shown here, but displayed as a floating point number. So we know that we have successfully grabbed or isolated the mean value, and we did it. If you're familiar with Python, this shouldn't come as a surprise. So we call the variable, and then we call the key, and we are presented with the value. So the key is minimum, and we call the key, and we're presented with the value 1000. So what we have to do is store that value in the variable wage stats min. So we'll go to the front, insert the value, and set an equal sign. And right now our value will disappear, because if we're creating a new variable, Pandas will actually not give us an output, and if we want the output, we have to call the variable name. We'll call the cell again, and now we have completed this part. Let's go to the next one. Check the type for wage stats min. Okay, we have created this variable. We can now again call the type function, the standard Python type function on wage stats min, execute the cell, and we see that it's a floating point number. So by isolating the actual value, we no longer have a series. What we have right now is a floating point number. Next challenge: get the max value from the wage euro series and store it in the variable wage stats max, return wage stats max. Okay, so this is very familiar. It should be easy to do that. Get the maximum value from wage euro. Okay, so the variable wage. Okay, get the maximum value from the wage series. Okay, so we will start out with our data frame. We will define the wage euro column that we want to work with, which will return a series. So we see that this is a series. We have the index that has been created, and we have the values here. Wage stats, and isolate the max value. So okay, we have our series, and we will call the aggregate method on it, and we will open up some braces, and we will call max. Let's execute that. We have the value. That's great. And now we will store it in wage stats max, which we will put in front of our expression, equal sign, and in order to return the value, we will actually insert a column and say wage stats max, and we'll run this, and we have our value again. Great. Let's check the type. This is of okay, wage stats max, and there's no surprises here. This is also a floating point number. Okay, let's get started with this challenge. Count the number of unique values in the nationality series and store it in the variable nationality unique series. The output must be a series, return nationality unique series. Okay, let's start with our data frame. We don't need the subset because we're only working with our column. We will pass in the column name. In this case, it's nationality, and we will then execute an aggregate function. And now I want to show you a different notation, and we will use curly braces, and then we will we will actually define the key, the key, and in consequence also the value that we want to see. So earlier we only applied the function, and now we will also define the key. So the key will be nationality, and what we actually want, the function that we want to execute is called NU unique. Let's execute this. Okay, so we have an error. Let's go down and see what's wrong. Non-unique is not a valid function. Okay, let's have a look. I probably misspelled it. Yes. The function is actually called non-equal. And let's do this again. Okay, and what we see here right now is that we have been successful. The key that we have defined, nationality, has actually been used, and we have the value of 160. If we would have defined the value differently, if we would have called the function like this, we would see that we would have the function name as the key, which is not optimal because it's the name is not, it's not very helpful in this case. So nationality, exactly. So we'll do it like this. We'll return the value and call it. So whatever you define here is actually defined as the key for our value, and now we have to store it in our variable nationality unique series. So I will insert this here, equal sign, and call the cell again, and there's no output. No, there's no longer an output, and we will call this, and now we have it. So we see that we have the option to not just accept whatever the name of the function is as the key, but we can actually use the dictionary notation or key value notation to define a key and the function that will actually be executed. So in this case, we have learned that in our data set there are 160 unique nations. Check the type for nationality unique series. Okay, let's do that again. Type nationality unique series, and no surprises here, it's actually a series. Good. Okay, let's complete our next challenge. Count the numbers of unique values in the nationality series and store it in the variable nationality's unique int. The output must be an integer. Return nationality unique int. Okay, let's start with our data frame. Limit the input to our nationality column and perform an aggregation function on the series. Okay, let's first call this. So we know that we have a series that contains the nationalities, so it's the content from the nationality column. Let's call the aggregation function and then pass in the method and call this. And what we see is, because we only pass one method and we haven't used the notation to create a series, key value pair, and as up here we haven't passed a list of functions, but we have passed a single function. What we are returned right now is a integer, so the value is 160. It's no longer a key value pair. And now check the type. So let's check the type for our, okay, now I need to store the variable. So nationality int equals, let's execute, let's call this nationality int, and let's go down here and insert up. Yeah, this is what happens if you're faster, if you want to do things fast. So this is better, and then we see, yes, this is an integer. That's wonderful. Okay, see you in the next section. Welcome back to the next section of this video. What we will do in this section is use the aggregate method on data frames. A data frame is at least one or more series, so one or more columns in our data is what's defined as a data frame. So what we will do right now is create a variable height weight, execute the following functions: mean, minimum, mean, and max on a data frame consisting of those columns height and weight. Okay, let's start with that. We call our data frame that we have imported from the CSV file, and we will reduce our column to the following names, to the following two columns. We'll insert them here, and then we'll execute this. And you see the formatting is different. The index has been created, but you see that the lines are formatted in different colors, and we have this header, and so this suggests that we're actually working with a data frame. So what we have done right now, we have created a data frame that consists out of the columns height centimeters and weight kilograms. And we want to apply the following functions. So we do aggregate and apply our list of functions. This is something that we have seen before when we're working on the serious data. So I'll execute the call right now. So what we see that has been done, we have a key value pairs again, the names of the keys, because not otherwise defined, are the function names, and we see them here: minimum, mean, and max. And we see the data, the aggregated data for both data columns. And watch round the result to 2 decimal points. So this is something that's really awesome in Pandas, that it can actually chain function one to another. So we can just add here round and add 2 and execute, and we see, okay, our values have been rounded to 2 decimal points. And what I haven't done, because I wanted to see the output while creating our function or creating our code, is I haven't inputted the name. I haven't created the variable, because if I execute the cell right now, we will not see an output until we call our variable again. So height weight, awesome. Okay, this is it. This is what we wanted to do. Okay, let's move on to the next point. Check the type of the height weight. Okay, let's do that. So type, let's make sure that we're actually dealing with a data frame. And yes, we are dealing with a Pandas core frame object, which is a data frame. Aggregate along the row of the variable height weight. Execute the following functions: count and sum. So let's do that. In a series, we only have one column and one dimension. In a data frame, we have actually 2 dimensions. And if you're wondering what it means to have 2 directions, I understand it this way. So in a table like this, in a data frame, in order to define this particular value, you need 2 pieces of information. You need to define the column, and you need to define the name of the row. If you don't define these 2 values, there's no way that you can get to this column, and this is what 2-dimensional data is. So in order to define a record in a 2-dimensional array, you actually need to give 2 sets of information. In a series, we have only one column. We only have to give the key name or the key index to clearly define a record. This is why a series is a 1-dimensional array. So what we're having here in a 2-dimensional array, we have axes. So we have one axis and another axis. And so we have the option to actually tell Pandas along which axis it should perform its operations. So aggregate along the row of the variable height weight. So we will start with our variable height weight, and we will on this variable call the aggregate function, and inside the aggregate function we will pass our list of aggregation functions. We have done this before, and before we let's call this actually. So what we see here is we see the count and the sum, and we see that the count is actually along the columns. So the count counted that the column height in centimeters has 3 records, 1, 2, 3, and the weight in kilograms also has 3 records. And then the sum has summed up all these records, so 152.40 plus 174.95 plus 205.74, and it came to the conclusion that the sum is 533.09, and it did the same for the weight column. So but this is not what we were asked to do. So what we will do right now is we'll define the axis and set it to 1, because by default the axis value is 0. So if not defined otherwise, the axis value is set to 0 in a data frame. So when we execute the function right now, we actually have a different result. We now go by the rows, and we see the count as the column now, and we see the count for the min row, so it's 2 records. So what we see here is the count is 2, and the sum is now between the height and the weight. So 152.40 plus 49.9 is 202.30. So this is how to use the axis parameter, and this is available to us in data frames because they are 2-dimensional arrays, and the axis variable is actually not available in serious data because we just don't have access there. let's start with the next section. We are going to pass the aggregation functions as a Python dictionary. So this is a possible way of passing in the aggregation functions, and let's go through the action steps. Reduce the data frame to the columns overall rating and value euro. So let's do that. We will use our standard data frame and we will insert our columns in here. So let's call this and see our results. We see the formatting, so we know that we have been successful in creating our data frame. And the two columns that we have used is overall rating and value euro. Okay, this is actually correct. Apply the functions standard deviation, standard error of mean, and the mean to the series overall rating. Okay, and apply the functions mean and max to the series value euro. So we will actually apply different functions to this series and this series. Why am I saying series? Because a data frame consists of rows, and the rows are series data. So what we will do right now is we will actually call the aggregate function. No, we will call the aggregate function .agg, and then we will start defining our values. So what we will do is we will open up our I will open up our curly braces. Okay, now let's start this process differently. I will just insert let's do it like this. Has this worked? I think it did. So this way we can actually insert line breaks and keep the code on one line and keep it nice and clean. So what we will do right now is we will define the series that we will work on, and our first series is overall rating. We will insert this here. This is our key, and then we will pass in our values. So the values that the aggregation functions that will apply are the following functions. Okay, and then we'll go ahead and define our second series, and on this series we will actually let me actually use the braces that I did. Let's do it like this. Overall rating and then value euro. Okay, and now we will pass in our aggregation functions that apply to this particular series. Okay, that actually looks good. Let's see if this call is actually successful. Okay, wonderful. So what we have done here is we see that we still have a data frame, but we have applied a set of aggregation functions to the overall rating series and a different set of aggregation functions to the value euro series. And wherever we don't have values because we just haven't applied that function, we have this NaN placeholder because Pandas doesn't allow for empty cells. So this is the way Pandas describes that there's actually no value for this cell. So what else do we have to do here? We have, yes, apply. Yeah, what we have to do is rating value euro-dict. This is what we will call this thing. And now we'll run it again and okay. Now let's insert this here and remove this one, and let's call this one more time. Wonderful. Okay. And now we will go ahead and call rating value euro-dict and call it. Okay, so I think this should be it. Return rating value euro-dict. This is fine. We have applied different different aggregation functions to different series, and yes, this is it. Great. Check the type for rating value euro-dict. Okay, this is by now, this is an easy task. Type and insert our variable and run it, and we see, yes, this is actually a data frame. This is good. Okay, passing the aggregation function as a Python tuple. This is actually even more verbose method to pass in aggregation parameters to the aggregation function. So create a variable called rating value euro tuple. We will do that at the end. We'll start out with our braces because this will be a very long line. Reduce the data frame to the columns. Okay, let's start with that. We'll use our data frame. We'll insert the columns that we'll be using. Let's insert those. Okay, I just missed that one. Let's remove this. Okay, so let's call this, and we see, yes, we have our data frame. It consists of two columns. That's fine. Apply the function standard deviation to the overall rating. Okay. We will now apply the aggregation function, and within the aggregation function we will define the label. So the label will be overall rating, because we're working with the overall rating now, and we will do the first method that we will apply will be the standard deviation, so std, and let's reduce the length of it. Let's do it like that. So this equals, and now we'll pass in our tuple, and as our tuple will pass in the overall rating. Okay, this is actually the column that we will be working on, and then we'll pass in the method std in this case. Okay, great. Then we will add a colon and start a new line. Yes, and on this line we will do the second value. So this will be, we'll just copy this, overall rating equals, let's copy this part and insert it here. So overall rating, but in this it's not standard deviation, it's SAM, standard error of mean, and this is fine, and this is, we'll replace this with Sam. Okay, let's move this a little further down the line. Okay, and we'll copy this again. Okay, this is not the way to do it. Let's do it this way. Overall rating mean, and okay, there we actually have a, where have I, okay, there we go. Great. Okay, so this is missing too, and this is missing too. Good. Okay, so we have overall rating mean, overall rating, and we will apply the function mean. Okay. And now let's add another line break to stay consistent, and so we have applied all three functions, standard deviation, Sam, and mean, to overall rating, and next one is value euro. So let's do that. Let's just copy the name, insert it here. Okay, value euro. What's our first? Minimum equals, let's insert a space here too, just to be consistent. So great. So, and we'll insert our tuples. So in this case, it's no longer the overall rating, but it's the value euros, and then we will apply or define the method that will apply it, which is minimum. Then we'll move on to the next one, and let's copy all of this over here, but we will replace the label with max, and this will remain, and this will replace with max. Okay, let's run this. Oh, wonderful. Okay, so let's look at the output, and we'll get a better picture of what's going on here. So what we have done here is we have created our data frame that consists of two columns. We have used the aggregation function, and then we started defining the labels for our tuple definitions. So overall rating standard deviation, this is the title that we have defined, and then we have defined the series that should be used for and what aggregation method should be used. So it's overall rating, and the aggregation method is standard deviation. So we see it's overall rating, and the standard deviation has been applied. And the same function has not been applied to the value euro. This is why the values are NaN. So, and we see the same here. We have the Sam label, the Sam function, we have the mean label and the mean function, and then we have value euro min and the minimum function, and max and the max function. So this looks good. The only thing we have to do right now is to jump up here and define the name rating value euro tuple. This is the name of our variable. We'll insert it here, and we'll add an equal sign, and we'll execute the cell, and let's return our rating value euro tuple, and we see the same result again. So we have been successful doing that. This is a very verbose way to define okay, he's not happy about that. So let me add another break here. Okay, so that we see all of that in one row. Okay, that's fine now. So this is a very verbose way of defining the aggregation function. So you might see this kind of definition. So it's good if you have had experience with this way of defining the aggregation functions. In the next section, we will look at aggregation method on grouped data frames. Welcome back to the next section of this tutorial video. What we will do here is use the aggregate method on grouped data frames. We will be grouping by a single column in our first challenge. So right now is the time to stop the video and try to complete the challenges by yourself. And I will start right now. So create a variable called aggregate. We'll do that at the end. As always, reduce the data frame to the columns age and wage euro. So let's do the data frame and let's reduce it to the 2-column age and wage euro. Wonderful. Let's execute this code and we see, okay, we have age and wage euro. Group the output by age, so we execute dot group and we'll pass in age as a parameter. Let's execute, and yeah, it's not group, it's group by. Okay, so group by age. Okay, so we have now a data frame that is a group by object. This is what we have arrived at this moment. Then we go to execute the aggregate functions, and let's copy our list of functions, add them, and execute again. And now we see our output. And so this is what you see here is a data frame, but this is a special type of data frame. This is a multi-index type of data frame, and you see there's this wage euro heading. It's way above here. Then we have the column names, and then we have the age as the grouping parameter in another level, and then we have the data. So what we see here is that in the age group of the 17-year-olds, there are 163 records or 163 players with a minimum wage of 1,000 and a maximum wage of 11,000, I think it's euros. And this group of 17-year-olds that consists of 163 players has a mean, I think it's wages, 1,588 euros a month. So this is what group by will actually return. And is this all that we have to do? Apply the functions, return. Yes. Okay, now we'll insert this variable at the front and set equal and execute. And right now we'll return age group wage euro. Yes. Okay, great. So this is our first grouped data frame. Let's see, return the columns for age group wage euro. Okay. So in order to return the columns, return the columns. Okay, yeah, let's do that. Let's view what actually our data frame, multi-level data frame looks like when we call columns on it. So we have this multi-index, and we see this is an object that consists of a list of tuples, and this is actually what a multi-index is. And this tutorial is about aggregation functions, actually working with multi-index data frames. Requires a few different techniques that we will not discuss in this video. What we will do is actually flatten the multi-index in order to continue with our tutorial. But you have now learned that the group by function will create a multi-index data frame, and this is actually the technical representation of what a multi-index is. Okay, create a new variable, age group wage euro flat, flatten the multi-index, reset the index, and save the new data frame into the new variable. Return the first 5 rows of age group wage euro flat. Okay, good. Let's start with the second task, actually age group. Let's call our variable age group wage euro, and then we execute drop level, and we will define along which axis we would like this to happen. So we are interested in the columns, and the level that we want is level 0, and then let's call this. Okay, and now we have still the age as the index, and we actually need to reset the index in order to be able to work with a flat data frame. So we will do reset index. Okay, let's execute this. Wonderful. So what we have now is actually the same data we had up here, but now we got rid of the multi-index and we inserted a new numeric index, but the information was preserved and we can continue working with that information. What we haven't done is we haven't saved it into the variable. Let's do this here, and actually yes, and then we'll insert the variable. Wonderful, and execute it again. Okay, so we're at this point right now. Okay, rename the columns from the data frame stored in age group wage euro flat to the following names. Return the first 5 rows of age group wage euro flat. The reason why we're actually doing that is because in our flattening process, this wage euro information has been lost. So there's a column that says mean, max, and minimum, maximum, and mean, but we don't know which series is actually involved when this minimum, max, and mean values were calculated, this information was lost when we actually flattened our multi-index structure. So here we see wage euro, and we know that the minimum value is actually related to the wage euro series. We don't see this any longer here, so it makes a lot of sense to rename the columns. So this is actually what we will do. We will call our variable, and then we will define some columns. So let's go in here, rename the columns for the data frame. Yes, let's get this going. Dot columns equal, and then we will provide our list of new column names in here, and then we'll execute, and we need to return our great. So this information, this list that we have defined here, has actually been applied to our data frame. And the information that was lost, so that we're actually talking about wages, has been returned to the column headings. Okay, great. Group by multiple columns. Okay, this is exciting. So what we will do right now is we will actually use our subsetting group by multiple columns. Group the data frame by age and nationality. Okay, let's do that. So let's start with our data frame, and then apply the group by function to it, and pass in our list, in this case, of parameters, and apply the aggregation. Okay, let's see here. We see our group by object again, and now we'll apply to that object our aggregation functions on the height centimeter column. Okay, use the following functions on the overall rating column. Okay. And the following function on the height column. So in the aggregate column, we'll actually use our dictionary. Then we'll use overall rating. So then we'll define the functions we actually want to run on overall rating. Awesome. And then we will move on, and okay, this is too long. Let's do our clean trick again, because this is gonna get too long. So let's break this here. And now the second cell is the height in centimeters. We'll insert it here, and then we'll go ahead and define it as a key and pass in the values or the functions in curly braces. Okay. Let's see what happens. Okay, wonderful. Great. So what we have done right now, we have used two columns to group by, and we see it here. So the age of the 17-year-olds is actually populated by certain nationalities, and then we see the overall rating column and the functions that have been applied to that column, and we see the height in centimeters and the functions that have been applied to that column. This is a multi-index again, and this is a very powerful function that Pandas provides us. Okay, in the next section we will look at custom aggregate functions. See you there. Welcome back to the section of custom aggregate functions. In order to introduce custom aggregate functions, it makes sense to work with filters first. So right now is the time to pause the video and try to complete the challenges by yourself. Okay, I will start right now. Create a variable filter rating. We'll do that a little later. Reduce the data frame to the columns overall rating. We're just gonna use our standard data frame. Well, it doesn't matter. We can also use the subset, and to the column overall rating. So wonderful. Let's execute this code. So we're experienced Pandas workers now, and so we know that this is serious, and so we have reduced our data frame subset to the series of overall ratings. Apply the condition larger equals 90. So in order to apply the condition, we're actually gonna call larger equals 90 and execute. And so what we get back is serious again, but now the values have been replaced by true and false values. So we have Boolean values that actually describe whether the particular value that was here in this column corresponds or is fulfills or doesn't fulfill the condition that we have set. And this is what pretty much a filter is. So in order to apply that filter, we will do the first condition. We will actually name that filter and set it to equal. And we already know that we're not gonna see much if we do that. So to maintain the output, we will actually insert our variable here and see the output. So check the type of filtering. Okay, let's do that. Okay, let's stick with type and let's insert filtering. Okay. This is actually a little bit too much. This is good. So okay, yeah, our experience tells us that that's a series, and the type function has confirmed our perception. Okay, use the variable filtering as a filter on the data frame. DF FIFA soccer players subset. Okay, let's do that. We'll insert the name of our data set, and then we'll apply the lookup function and pass in our filter. So let's execute. When we look up here, we actually see that all those records that were assigned to the Boolean value of false are no longer part of our data frame. We see that this is a data frame because the formatting is yeah, the way it is, and we see that all the players have an overall rating of above 90, and this is the elite of the elite. Okay, now we have learned how to apply filters, and now we'll go on to Lambda functions. Welcome back to this section of the video. We will now talk about Lambda functions. We started our custom aggregation function topic by using filters, and we have looked at how to create filters. Now we will use a Lambda function to pretty much get to the same result in order to create this list of tuples and essentially get a filter. Please pause the video now and try to complete the challenges yourself. I will now start working on the challenges. Create a variable field rating lambda. We will do that a little later. Reduce the data frame FIFA soccer subset. Let's start with that to the columns overall rating. Okay, let's execute that, and we actually see that we have a series here, and it is our overall rating series. Use a Lambda function to apply the condition greater equals 90. Okay, let's do that. So we have here a hint that we will actually need to apply the Lambda function, and in order to do that, well, it will fail. We will try to do that on a series. So let's make this a two-dimensional array, a data frame, I mean. Okay, you saw the difference of what just happened. Without those second square brackets, we have a series, and if we try to apply the apply function to that series, we'll actually get error. Okay, but let's just do that. Lambda functions are so-called nameless functions, so we're not actually defining a name. The X here actually defines what was predefined here up until the point apply. So in our case, this X represents the series that we have defined here, and we will work with that value X, and we will apply the greater equals 90 method, and let's run this and see the error. So it's actually int object has no attribute greater equal, and the only reason we have an int object is because this is because we started out with a series, so we need to start out with a data frame, and let's run this again, and now we see that we are returned a data frame consisting of overall rating, true and false values, but this is not what we had here. Here we had a series, and in order to get that out of our data frame, we actually, there's a method called squeeze. Let's do that. Squeeze. Okay, let's apply squeeze, and now we get a series. We can actually apply squeeze when we have just one column, and then the data type is reduced from a data frame to a series. So by applying a Lambda function, we actually created the same output as we did here with our filter syntax. Okay, what we need to do right now is we need to name this variable because we will be using it in the next step. This is not the way to copy in Pandas. So let's insert this. Let's do that. And now we need to output our result filter lambda. Okay, go. Okay, check the type of filter rating lambda. Yeah, we already know what a series looks like, but let's do that. Filter rating lambda, insert and execute, and yes, this is a series. Use the variable filter rating lambda as a filter on the data frame df FIFA soccer player subset. Okay, we'll just use our data frame, and then we'll use the lookup method and insert square brackets and insert our filtering lambda variable in here, and let's execute. Okay, and this is exactly the same output that we are presented with up here. So the reason I did this is because I wanted to show you what's actually happening with the lambda function, what this x represents, so you get a better feel for what is going on. In order to use lambda functions or any other kind of functions in Pandas, we actually have to use the apply method. So, great. Use the variable filter rating lambda as a filter on the data frame df FIFA soccer player subset. Count how many results were returned from the individual columns. So we can pretty much copy this line down here, and now we need to count our results. Count and return. And so what we returned are the individual columns and the amount of records that each of them contains. So we have nationality, age, height in centimeters, and because we have no unknown values, all those values are 16, so we can extract from this the understanding that there's actually 16 players out of the almost 18,000 that have such a high, that have a rating above 90. So we're talking about the elite of the elite. Repeat the previous task. Apply the variable filter rating lambda inside a lambda function as a filter. Okay, good. Let's do that. We'll start out with our subset. And then let's just return our subset. So our subset is a data frame. This is what we see. And on our subset, we will now apply a lambda function. We'll take our data frame as an input, and on our data frame we will apply the lookup method, and we will insert the same filter. And yes, let's execute that. And now what we will do is we will apply the count function. Let's do that and execute. Okay, and we get to the same result. So now you might ask, why would I write a Lambda function if I can totally avoid doing that? And the answer to that will come in the next challenge. So if you haven't completed those challenges, please don't forget to stop the video and try them yourselves, because this is actually a wonderful way to learn and remember how to actually do that. Group the data frame FIFA soccer players subset by nationality. Okay, let's do that. We'll insert the data frame. We apply the group by function, and we'll insert our we'll insert nationality in here. Okay, let's execute this. We have our data frame group by object. This is actually what we wanted to have, and now we will just apply the lookup, use the variable filtrating. Okay, let's do that and insert our filtrating lambda filter and execute. Okay, good. And now we get an error. Attribute error, data frame group by object has no attribute lock. So now if we try to apply the lookup method on our group data frame, we're actually informed that the lookup method is not an option on a group data frame. So I will let this error sit here, because this is a good reminder that we can't just use this method everywhere. It doesn't work on group data frames. So right now we'll use the Lambda function to get around this problem. So group the data frame subset by nationality. So dot group by nationality. Right, do we have here a space? No, we don't. Okay, good. And then apply the variable filtrating inside the Lambda function. Okay, so in order to use a Lambda function, we need to actually use apply, and then we'll use Lambda, and then we define the input with x, and then we have x, and we'll use the log method providing our filter. Okay, let's execute our code. Okay, and we see now we have grouped by nationality, and we see our subset, and those are the players from each from each country or nationality that actually passed that above 94 overall rating line. And we see that Spain has actually 1, 2, 3 players that have such a high rating. Yeah, I have no clue how to read that. Belgium also has 2 players in this very high rating level. Great. So what we saw right now is that there are certain times when applying a Lambda function is actually a wonderful way to work around limitations. And this is one of those situations. Let's look at the next challenge. group the data frame soccer player subset data frame by nationality. Okay, we have done that many times now. Let's just copy that. Great. Okay. Reduce the grouped data frame to the column overall rating, age, height, centimeters. Okay. So in order to do that, we'll insert our square brackets and be a little lazy and copy this in here. And let's execute. Okay, so we have a data frame group by object, and this is what we would expect because we're grouping by nationality. Okay, what else do we do? Okay, let's introduce our syntax that will allow us to not cross the line here. Okay, so what are we gonna do now? We will now apply the variable filtering lambda inside the lambda function as a filter. Okay, so what we'll do now is we will do apply lambda x dot log, and we will fill in our filtering lambda. Let's see. Yes, this is not how it works. So this is much better. Okay. So let's close this and run this again. Wonderful. Okay. So what we have right now, we've actually reduced. We're still grouping by nationality. We have the index values, but we have reduced the unnecessary columns because with nationality here and here. And now this is a beautiful data set to do further investigations on. Welcome back to the last section of this video, where we will dive deeper into the access parameter of the apply function using the lambda function. So we will there is something very interesting here. When I was playing with this data set, I saw height in centimeters and weight in kilograms, and whenever I see those two values, there is one calculation that has to be done. There's no way around it, and it's the body mass index. So what we will do in the last section is we will actually use the apply function and the lambda function to calculate the body mass index for our top of the top players. So we will start with things that we can almost do in our sleep right now. So I would ask you to pause the video right now and to try to complete the challenges by yourself, and I will now start working on them. Create a variable df_bmi. We'll do that at the end. Group the df FIFA soccer player subset data frame by nationality. Okay, let's do that. We'll do that, and then we apply the group by function. Group by, and we will insert nationality in here, and we'll execute that, and we'll get an error. Okay, yeah, this is one. There's a D missing. This is why I was getting no auto completion. on the group by. That's perfect. So what we have is a data frame group by object. This is exactly what we would expect to happen here. Then reduce the group data frame to, in order to reduce a data frame, we need to add some square brackets and then another set of square brackets to represent the two-dimensional nature of a data frame. Let's insert this, let's execute, and now we'll actually see that we have a different type of data frame group by object. It contains less columns. Apply the variable filter rating lambda inside a lambda function as a filter. So what we will do is we will do the apply method, and in here we will say lambda x dot log, and actually use our filter rating lambda filter. Okay, let's run this. Okay, so what we have done to the previous exercise is we have just removed the overall rating because it's not interesting for us. And so what we have is a data frame group by nationality, and we will now work with that. We have, you see, there's this nationality is actually the index column right here, but this is actually it's not gonna help us with our calculation. So for data, I forgot to. It's always difficult if you leave something for the end and then you don't do that at the end. That's not good. Okay, so let's do this and go out here and call df_bmi and execute it. Okay, so we have our variable data frame bmi. It's a data frame and it will be for our BMI calculation. And first we need to reset the index, so we'll reference df_bmi, and then we'll just reassign it to df_bmi dot reset index. Execute, and let's return df_bmi. Okay, so I've done it twice. Okay, so what we have now is the index. With the index column, let me fix that real quick. So the best way to do that would be let's execute this again. So we have a new df_bmi, and now I've just re-executed the upper code to have a clean df_bmi cell, and then I've executed the code only once, and now we have reset the index. Great. Okay, so what's return the df_bmi? What's the next challenge? Add new column named BMI to df_bmi. Okay, let's start with that df_bmi, and we will add a new column called BMI. So we've done that, and this column will actually, we will now define what will be in this column. Calculate the content of the new column using the lambda function, formula weight in kilogram, height in centimeters, applied to each row. Okay, so we will work with our data frame df bmi data frame, and we'll apply our lambda function to that data frame. So x is our data frame, and we'll pass in x to our calculation. What we're interested out of x right now, out of our data frame, is the weight in kilogram column, because this is the beginning of our formula. So weight in kilograms. So if we want to get that specific column, we need to actually reference it. So we reference the df BMI data frame, and then in square brackets we'll actually get the weight in kilogram. So I'll insert it here, and I give it some brackets. Yeah, okay. So what do we need to do? Weight in kilograms divided by height in centimeters. Okay, this will be easier this way. So in order to reference height in centimeters, we need to reference our BMI data frame. So we do that by referencing x, because this is what we have passed in to our lambda function. So our df data frame BMI data frame object is represented by this x. So by calling x and square brackets, and then actually getting the height in centimeters, we are actually referencing this value. Let me insert this. Height centimeters. Okay, then we're one step further. So we now have height in centimeters, and we need to divide that by 100. Okay, we divide that by 100, and then what do we do? And yeah, square by 2. We square it by 2, and okay, this is what we have right now. And we need to do these calculations not along the columns, but along the rows. So we're not interested in, what we're interested in is the weight of a particular athlete and the correlation between his weight and his height as defined by the formula of the body mass index. So we need to define the axis. We have done this before. Axis equals 1, and we'll close our column, and then we'll execute. Let's see. Okay, he's not excited about that. Let's see where I dropped one. So we have BMI apply. Okay, BMI div apply lambda. Where's this one? This one is, this is here. Okay. Okay, so we need to create another one. Yeah, this is where one's missing. Let's run this. Okay, good. And to see the output, because we have defined a new variable, we're not going to see an output. So let's do that. Okay, so we have the new BMI column. It was added at the end of our data frame, and it actually contains sensible BMI values. And what else? Is there something else? Yeah, round the result to a whole number. Okay, let's do that. Dot round and execute. Okay, great. So we have created our new column and populated it with the body mass index values. I hope this has been useful to you, and enjoy. Bye.